Good morning dear friends, welcome to Electrify Engineering channel. So today we are going to learn about what is mean by source transformation. In the last class we have seen what is mean by what is nodal analysis, what is mesh analysis and how one can do the problems related to mesh analysis and nodal analysis. So when we go through the further problems, there is a requirement of conversion of voltage source to current source and current source to voltage source. Normally, when we do the nodal analysis, sometimes we need to convert the voltage source to current source. So when we do the mesh analysis, we have to convert current source to voltage source. So sometimes some requirements will come. During this time, I will explain to you. However, today we are going to learn about what is meant by source transformation. Already we seen two sources, voltage source and current source. Then dependent, independent sources are dependent sources are also there. I will explain it in the further classes. Today we are going to concentrate on independent sources, voltage source and the current source. So normal, if we have the circuit is like this, here we have the electrical network or circuit. We have the series resistance like this, and the voltage source is positive, negative. This is the voltage source is connected in the network. Okay, connected in the network. That this is, we can write this resistance value as R. We can say source resistance RS. This is the supply voltage Vs. This is the entire network. So that can be converted into the current source. So this is called as voltage source, right? So this is called as voltage source. Voltage source. We are converting that into current source. So before converting to the current source, we should know what is meant by the voltage. What is mean, what as per the Ohm's law, what is voltage? Voltage is equal to current in the resistance. So now the current is nothing but voltage divided by resistance. These two formula you are already familiar with that. Now I am going to convert that into the current source. For that, if you see this here, the same, I am converting that into the current source. So this is the current source. Here we have written minus plus. That means voltage rise. Assume this is the direction, voltage rise. So therefore current direction also like this, minus to positive. Then this resistance has to be connected in parallel to the circuit. Here it is the voltage resistance is connected series with the voltage source. Here what we have to do, we have to connect this parallel with the current source. Then the remaining network we have to consider. Network is, there is no change in the network, we have to use as such. So this is the network. So now this is the resistance. Okay, so the resistance I am writing here are same resistance only, but however the current value will be current I is equal to, as per this formula, V by R. So this is called as source transformation. That means voltage source is converted into the current source. Voltage source is converted into the current source. Similarly, for in vice versa, that means if you assume that we have a current source, then if the resistance, one of the resistance is connected in parallel, that value is Is. So this is the current source I, and this is connected to the particular network. This electric circuit is having many components inside the entire network that can be converted into the voltage source. So for that we are using, this is the voltage source. Voltage source here positive, negative. Current direction is up, so that rise voltage minus is in the below, and this is a positive, so this is the voltage. Then we have to connect resistance in series. So the resistance is called the same resistance Rs, we have to connect here. Then we have to use it the particular network. I hope you understand. Here voltage source is connected series with the resistance. Here the current source connected parallel with the resistance. So when we convert this to that, the position of the resistance will be different. Similarly, the voltage here, when we convert voltage source to current source, this is nothing but Vs. Okay, so this is nothing but supply voltage Vs. Supply voltage Vs divided by R. Similarly, this voltage V here I we can consider it as supply current. So Is. Now I am going to write the supply voltage Vs is equal to, as per the Ohm's law, Vs is equal to Is into Rs. So likewise we have to do it. For example, if you see this one circuit, we have some, this is the voltage source, positive, negative voltage source. Then the voltage source value is around 200 volt. Voltage source value is again 200 volt. Then here the one resistance is connected. The resistance is 2 ohm. Then we have another one resistance here. Maybe this is 3 ohm. And we have another one voltage resistance like this. This is for your understanding, for 4 ohm and 2 ohm resistance. Okay, 4 ohm, 2 ohm resistance. Now I want to convert this voltage source to the current source. So voltage source to current source. In this voltage source, one resistance is connected series with the voltage source. So now I am going to convert that into the current source. For that, this is the current source. I is equal, this is the voltage V, current I is equal I, and we have the resistance has to be connected in parallel. This resistance is connected in parallel, therefore 2 ohm. Then we have remaining resistance, we have 3 ohm. This is 3 ohm. Then 4 ohm and 2 ohm. 4 ohm and 2 ohm. So now what is the value of current? Already we know current is equal to V by R. Therefore I is equal to, here current source value I is equal to, supply voltage is 200 divided by the respective resistance 2 ohm. So that is equal to 100 amps. So that this is the current source value is 100 amps. So similarly, when we do this in another way, that means current source we are converting to the voltage source. For that we can use another one example. We have the current source of 50 amps, and here one parallel connection of resistance is 2 ohm. Okay, parallel connection of resistance is 2 ohm. Then we have another circuit component 5 ohm, 6 ohm. Then here one voltage source, if you have the voltage source V is equal to 10 volt, assume like this. So now we are converting that into the current source. This is converting that into voltage source. So for converting to the voltage source, what is the procedure? We have to connect this resistance, parallel resistance to this 5 ohm. 2 ohm is connected parallel with the 50 amps current source. So now we have to connect this series with the resistance, series with the source. So therefore we are converting this voltage positive negative. This is the supply voltage, and we have the resistance 2 ohm. Then remaining we have 5 ohm, and we have 6 ohm, and the supply voltage here 10 volt. So now I want to know what is the voltage V. V is equal to this particular current source value into the particular resistance. V is equal to what? As per the Ohm's law, V is equal to I into R. Therefore 50 into 2, that is equal to 100 volt. So likewise we have to, in some situation wherein we have to convert current source to voltage source, or vice versa, in order to make the problems in little more easiest way to find the solution. For that, very much important, this voltage source to current source and vice versa. I hope this topic is very much interesting and understandable. Those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.